Now, example number 3.6. The figure is given to you in this example. Okay, there is a battery of 10 volt of negligible internal resistance is connected across diagonally opposite corners of the cubical network, which consists of 12 resistors, which are having their resistance of each wire to be 1 ohm. Determine the equivalent resistance of the network and the current along each edge of the cube. Now try to understand, this is the figure. Here, this is your 10 volt battery. Now see, when the current comes out from the positive terminal of the battery, then you can understand that from this point A, it will be divided into three parts, and it is a symmetric figure because each and every edge is having 1 ohm resistance. So this resistance which are there in each edge is having the value to be 1 ohm, and it is a symmetric figure. Okay, so the current which is coming here at this point A will be divided into three parts, 1, 2 and 3. So we take this current which is coming out from the positive terminal as 3I. So you can divide it easily in three parts, that is I, and the third part also I. So try to understand, this current which is coming out is taken as 3I. So it is divided into three same parts, I, then in this also the current is I, and here also the current flowing is I. Now this current, say this I am talking about, reaches here at this point A prime, then again it will be divided into two parts. Now again symmetric figure, so here I by 2 current goes, in the other part also it becomes I by 2. Then you take this AD, this other color I show, okay, say for example AD branch you take, then that current I which reaches at this point D will be divided into two parts again in I by 2 and I by 2, you can see in this figure. Then at this B point this current comes, okay, and that is also divided into two parts, that is I by 2 and I by 2. Okay, so you can understand the current distribution from this. Okay, so now again this I by 2 current is reaching here at this point B prime. Now at B prime two I by 2 currents are coming, this I by 2 current and this I by 2. So I by 2 and I by 2 will make the current I here. So here current I it becomes. Similarly in this BC branch, the I by 2 current reaches at this C and I by 2 from this DC will reach. So here again I current flows. Okay, so you can distribute the current easily in this way. Whatever I current, I and I. Okay, I and I. Then this I reaches at this B, it becomes I by 2 and here also I by 2. Then this AD current reaches here at D will become I by 2 and here also behind I by 2. Then this reaches at A prime, this, okay, then this becomes I by 2, this also becomes I by 2, that is in AD prime branch. Now AD prime, D prime you consider, at D prime which currents are coming? From DD prime and from this AD prime. So I by 2 and I by 2 are reaching here, so it becomes I here in this branch. Similarly, through this, say this is a point A prime, B prime and B prime. These two I by 2 current are reaching at B prime and it makes I by 2 plus I by 2 becomes I. Similarly from DC and this BC, you consider this C point, there also I by 2 current comes this also brings I by 2. Both I by 2 will make current I in this branch, that is C prime. C prime will become I. So all I plus I plus I will become 3I. Okay, so finally you get 3I current out of this C prime point. Okay, so it is very easy to distribute the current. Here you are dividing it into three parts, that is I, and I. Then this I will be divided into I by 2, I by 2. This I is also dividing into I by 2, I by 2. And this I is getting divided into I by 2, I by 2. Then this I by 2 and this I by 2 are meeting here to make I. Okay, to make the current I. Similarly, this I by 2 and this I by 2 are meeting here to make the current I. Okay, similarly here at this B prime point also, this I by 2 and this I by 2 are making the current I. So totally at C prime point, I plus I plus I. So it becomes 3I. So current entered was 3I. Current which is leaving from the cube is also 3I. So our current distribution is correct. Now what to do? Now you take the loop A, B, C, C prime, then you come this side to A. So which loop are you taking? You are beginning it from say A, then you go to B, okay, then you go to C, then you come to C prime, okay, this way, and then in this direction you go via battery, that is E, okay, A, B, C, C prime, E, and then you are reaching at point A. So A to A you are coming, but this way. This is a closed loop which I will take and apply the Kirchhoff's second rule. Okay, so I begin this way. Okay, say for example, you have to now keep your figure in front of you, otherwise you will not be able, or I write it here. If you are moving from A to B, then you are with the current, so it becomes negative minus, and the resistance of this we take, suppose R. It is 1 ohm, but right now we write R. So with the current minus I into R. Now in this direction B to C, again minus, with the current you are going, so minus current multiply by the resistance. Okay, then C to C prime, again with the current, so minus, okay, minus I into R. Okay, and this way you go, this way, and this way, then you are moving from minus to plus. So plus E is equal to 0. So this is your equation. Now you can simplify minus IR, and minus IR will become minus 2IR plus this I by 2. So total it becomes 2.5, that is 5 by 2 IR with negative sign plus E is equal to 0. So we can write E is equal to positive 5 by 2 I into R. This is your first equation. Now we want to find out equivalent resistance between A and C prime. This A point we consider, okay, and this C prime point. So remove this whole cube and put the resistance here between these 2 points, which is equivalent resistance of cube, and we take this as Req. So the figure will become, say for example, the figure will be like this. You have this, okay, this battery was there, then okay, in between these 2 points the whole cube was situated. Now instead of that cube we put another resistance whose value is equivalent to the resistance of the cube. So the current should be 3I. If that resistance Req is same as that of the cube, then the current should not change from that battery, which is of 10 volt. Okay, so the current must be 3I, which is coming out from positive terminal. Okay, now Ohm's law you can apply. Okay, we take E is equal to 10 volt. So E is equal to I into R. But here current is 3I. Multiply by resistance is R EQ. Okay, so 3I into R EQ. Now that first equation was E is equal to 5 by 2I into R. So compare these two equations. So you will have the equation. Okay, what is the new equation which we got? 3I R EQ, which is equal to 5 by 2 I into R. So I will be cancelled out. Okay, so now you can write R EQ is equal to 5 upon 6 times R, and the value of R, that is resistance of each edge, is given 1 ohm. So R EQ will be equal to 5 by 6 into 1, so it becomes 5 by 6 ohm. So resistance of that network is 5 by 6 ohm. Okay, now you want to find out the current. Okay, now as you know that Req we got, it is how much? Req is equal to, we got the value 5 by 6 ohm. Okay, so now if you want to find the current, okay, then voltage is equal to current, that is how much we have taken? 3I. Okay, 3I is the total current which we have taken, multiply by Req. So 3I, that is total current which is coming out from the positive terminal of the battery, is, now E is 10 volt divided by 5 upon 6. So this becomes 60 divided by 5. Okay, so this becomes 12 ampere. So 12 ampere will flow. Okay, and now from each branches, total 3I is how much? 12 ampere. So total current which is coming out is 3 ampere. So here from this figure you can understand now that total current is 12 ampere. Now 12 ampere is divided into 3 parts. So 4 ampere each will go through this A, B, AD and AA prime branch. Then this 4 ampere will be divided into 2 ampere and 2 ampere. Similarly, all these 4 ampere current, if you consider here at this B, then again it will be divided into 2 amperes. This 4 ampere which is here will also be divided into 2 ampere. So in each branch you can write the value of current now. Okay, the current flowing in each edge can be now easily understood from this figure. Okay, thank you.